Hello everyone. I am providing a demonstration video for the potentiometric determination of KHP for CAN 3452. The overall chemical equation that we're going to be following is sodium hydroxide with the addition of the potassium hydrogen phthalate, which yields water and sodium KP. And ultimately what we're going to be doing is learning how to use a pH probe, how to calibrate it, and then also how to measure and titrate it experimentally so that we can ultimately plot the as received pH versus volume graph and then take the first and second derivatives of those functions. What we're going to be doing is that we're going to be preparing 0.1 molar sodium hydroxide and titrating it into our KHP solution. First we're going to be standardizing the sodium hydroxide. We need to standardize the sodium hydroxide because this will confirm the sodium hydroxide concentration that's been prepared. And by confirming the sodium hydroxide concentration, this will give you a more accurate and precise representation of your plotted graphs, and it will give you a better calculation for your KHP concentration. From there, we'll follow the same equation that we've already used has been shown to you in the semester, where we're just going to be taking our mass of KHP, converting that into moles, and then ultimately calculating the molarity of the sodium hydroxide. You're going to complete 3 trials of that and then calculate the average and percent relative standard deviation for those. You're also going to be running determination of hydrochloric acid experiment. We need to confirm, this is to confirm the proper pH probe calibration, which will also show you how to calibrate that in this video. So previously we've used an indicator, but now we're not going to be using an indicator because we're going to be using a pH probe to do our acid-base chemistry. We're going to be determining the percent KHP in the unknown. We did the standardization already with the pure KHP. Now we're going to be confirming the percent KHP of an unknown percentage. We're going to be using the pH probe to track the change in pH over volume. And so whenever you're writing out, whenever you're doing the titration, you want to keep track of the pH that's being monitored by the probe and also the amount of solution that you've added. Because you'll need to plot a graph like such. These graphs you've already seen before on pH versus volume change. So you need to start out initially at small intervals of maybe starting with 1 milliliter increments. Then as you get closer to the equivalence point, you want to go to maybe 0.1 milliliter increments so that you can have the best quality graph that will show you exactly where the equivalence point is. And then you'll continue after you've reached past the equivalence point until the pH curve stabilizes. You don't want to stop too soon, otherwise you won't be able to reach a stable graph, and you want to make sure that you're beyond the equivalence point. Our equivalence point is going to be here in the center, and so whenever we want to try to figure out more data on the equivalence point, we can take the first derivative of that graph. That graph is something that you can plot in Excel, and then from there you can take the first derivative, and then you'll get the first change in the equivalence point, which will be at the peak. So essentially, you're just taking your as received non-derivative function. When you take it to the first derivative, you're going to see this mathematical operation, which is just showing the change in the equivalence point, or the change in how the pH changes as you continue adding more and more of your solution. You then need to go to from the first derivative to the second derivative, and so from the first to second derivative, you'll find that your equivalence point is right here at the balance 0 point. And so from there, you'll take your second equivalence point here to derive the amount of KHP that is in the unknown. So we're first going to begin with the standardizing of the sodium hydroxide. We'll show you one example titration. We've prepared pure KHP by measuring out 0.7707 grams and dissolving it into water in this Erlenmeyer flask, and then also adding 4 drops of our indicator, phenolphthalein. And so we have our sodium hydroxide already put into the burette. Now going to add the sodium hydroxide, and we'll look for the endpoint. The solution should go from clear to around a pinkish color, And so let's see what happens. We always want to make sure that we're swirling it. You also want to make sure that you keep track of your starting volume point. Here we started at 0.2 milliliter mark.
We're just going to keep titrating until color changes permanently. We're around 19 milliliters right now.
We're around 25 milliliters. As you can see, the color is starting to become more, it comes to stick around a lot more. So we're just gonna change it to drop.
We're around 31 milliliters right now.
Very close to the end point now. Just gonna slow it down to maybe drop a second. Looks like we're at our end point. We ended at 36.4. I'm going to show you how to set up the pH probe for calibration so that you can use it for the remainder of the experiment. And this black bag that should be set here on your table should contain the pH probe, a small screwdriver, and 3 small bottles of water, pH 4 buffer, and pH 7 buffer, along with your pH probe. And your pH probe should be immersed in chloride solution or electrolyte solution so that it does not dry out your pH probe. And you should also try to use a deionized water bottle so you can rinse off your pH probe. So it's pretty simple to calibrate. If it doesn't turn on, then we can just find another one that has batteries or just switch out the batteries. So right now it's showing initial pH of around 6. So I'm going to take my probe out and I'm just going to just rinse it briefly with water. I'm going to begin with the pH 4 buffer. So I've rinsed it with water. I'm just going to dip it again into this water here. And then place it into the pH 4. So now we are measuring the pH of the buffer solution. But as you can see, the pH probe is not calibrated. That's something that we have to do. Well, I don't really think this through, did I? So what we're going to do on this right side here, there's a small casing. You can just use a screwdriver to pop it open. And as you'll see here that there's two dials that you can adjust with the flathead screwdriver for pH 4, pH 10, and pH 7 calibration. So I'm going to first place the screwdriver into here. And I'm going to increase, I'm going to go clockwise to increase the pH until we're at 4. can be a fine adjustment. So now we're at pH 4. It may fluctuate by 0.02 digits here and there. So now I'm going to rinse again to get the buffer solution off. Just make sure you have a waste beaker. I'm going to leave this here while I just open this. Move the pH 4 out of the way. Again, I'm going to immerse it in water real quick. Then now I'm going to stick it into my pH 7 buffer. So my pH 7 buffer is reading closer to 8. It's around 7.95 or even 8. So I'm going to do the same thing, but this time I'm going to calibrate it to the pH 7. This time my pH was higher, so I need to go counterclockwise until I reach pH 7. And there we go. I will just close the side casing again. And then I'm going to take the probe out of the buffer solution, and I'll rinse it again with water. And then now the pH probe should be calibrated so that we can move on to the standardization or determination with hydrochloric acid. Yeah. Now we're going to be continuing our experiment by confirming that our pH probe is calibrated by having hydrochloric acid down here in our beaker, and then our already measured and calibrated sodium hydroxide. So what we're going to do, we're going to make a chart. It may be easy, however you want to do it. I have it started laid out, so I'm starting at 0.3 milliliters with our initial pH of 0.43. And then we're going to measure at the 0.5 milliliter mark, and then go at every half milliliter to start off with. As you get closer to the equivalence point, you're going to see that the pH is going to start moving or increasing a lot faster, and then it'll stabilize as shown in that pH curve. What you need to keep in mind is that as you get closer to that equivalence point, you need to go at smaller pH smaller intervals of sodium hydroxide added, so that you can track those pH changes. Okay, so we're starting at 0.3 milliliters. What you should do is that you should, every interval mark that you're going to measure at, you should go ahead and pause your titration, just so that you get the best and most accurate results. So I'm going to add 0.2 milliliters, slowly increasing. Days. Okay. So I've added 2 milliliters. Let's go ahead and just go to 4 milliliters for the sake of this video. You always want to make sure that something that we forgot to mention, you always want to make sure that you're swirling your beaker again, so that it's in equilibrium when you're measuring, and also that your pH probe needs to be fully saturated into the solution. So make sure that you cover that. So we're at the 4 milliliter mark now, and so we are at 0.53 on our pH. Going to go to the 6 milliliter mark now. Okay, we're at 6 milliliters.
pH is 0.58. Go ahead and go to the 8 milliliter mark. We're at 0.66. We're going to go to 10 milliliters. We're at 0.76. 0.77. Okay. go to 12. pH just jumped a lot. Maybe we should go back to just 1 milliliter intervals now. Again, I think we're getting closer. Starting to see that change more. So we just jumped from 0.77 to 0.89. Just gonna add the 13 milliliter mark now. At 13. 14. We're at pH 1.07. At the 15 milliliter mark, 1.20. Gonna start back up here. .36, 17. Yeah, so we're getting closer now. So we just jumped, started 1 milliliter, and now we're at 1.59. So pH jumps by 0.2 now. Yeah, we're getting closer now. And we got half milliliter intervals. So we're really close now. 18.5. Should I keep going at half a milliliter? Maybe 0.25. See that? Actually, I'm at 18.5 right now. Yeah.
Oh. Well, see, yeah, we overshot it a little bit. We added too much. We should have gone even adding point 0.3 milliliters. It's gonna shake it up a little bit. So now we're at 18.3, or sorry, 18.8, and we're now at pH 5.58. So now we've gone past the equivalence point. We've essentially transcended from acid, and now we're in basic conditions. And so that is now at 18.9, and we're at pH 9.81. So after this, you're just going to continue adding slowly. For the sake of time, we're not going to go through it too much. You're just going to keep adding dropwise, slowly until you've gone and you've stabilized the curve. Because we started at the acidic conditions, and then we slowly moved up, and then we jumped quickly to the basic conditions. So, and then we're just going to keep adding until we have reached a stabilized point by adding our sodium hydroxide. Okay, so we're going to continue on to the final part. You want to make sure that when you're finishing the second part for the determination of hydrochloric acid, that you again rinse your pH probe with water to remove the previous residue, so that does not alter your pH for your next measurement. The pH for our unknown KHP solution is right around 3.2. What we're going to do is that we're just going to begin adding dropwise to our solution, and I'll just read out the volume markings so that you can follow along with the pH. So we're starting at a volume of at the 3 milliliter mark. So we're starting at the 3 milliliter mark, and so I'll just read out originally at every 0.5 milliliter marking. Then we'll slow down as we get closer to the end point. Remember that our standard KHP took around 36.2 milliliters. And so if we have an unknown, that means that the total volume that's needed to add should be less. So I'm going to go ahead. We're starting at the volume marking 3. I'm going to just open my burette just enough so that it begins to just individual drops. We're at the 3.5 marking. .0 milliliters. 4.5. 5.0. 5.5. 6.0. 6.5. 7.0. 7.5. 8.0. Go ahead and add until the 8.5 milliliter marking. Okay, so we're going to pause at 8.5 milliliters. Remember, we started at 3.0 milliliters on the burette. Our pH is now around 3.77. Going to slow the drop rate further so that we don't go past the endpoint. Nine point 0, 9.1, 9.2, 9.5, 9.7, 10.0, 10.2, 10.3, 10.4, 10.5, 10.6, 10.7, 10.8, 10.9, 11.0, 11.1, 11.3, 11.5, 11.7, 12.0. Okay, I've paused it currently. We're still at 12.0. $12.5. 13.0. 13.5. 14.0. 14.5. 15.0. 15.5. 16.0. 16.5. 17.0. 17.5. 18.0. 18.5. 18.5. 19.0. Gosh, it's taking a while. I guess it's okay though. 19.5. 20.0. We're almost there. 20.5. 21.0. 21.5. 22.0. 22.5. 23.0. 23.5. 24.0. 25. I'm sorry, 24.5. 25.0. 25.5. 26.0. 26.5. 27.0. 27.5. 28.0. So our starting pH right now is right around, or sorry, starting volume is right around 28 milliliters. And continue. Again, you want to make sure you're going slow so that you're tracking the volume change with pH. You slow it down just a little bit. So we're at 29.0 milliliters. $29.5. 30.0. 30.5. 31.0. 31.5. 32.0. 32.5. 33.0. 33.5, 34.0. What the heck? 34.5, 35, 35.5, 36.0, 36.5, 37.0. This is not working properly. 37.8. There we go. So I'm sorry, that was 37.5. Now we're at 38.0. 38.5. 39.0. I'm going to keep going after the equivalence point. 39.5. 40. 40.5. And we'll stop at 41. All right, that's our titration. Yeah. To finish up, we are going to share our values with y'all. So with our known pure KHP, we started with 0.7707 grams, and when we started at 0.2 milliliters, we ended at 36.4. And then when we did our unknown KHP with our pH probe, we used 1.0039 grams. And so we actually are going to have to end up using potentially more solution than because we have more KHP in there, depending on the unknown. And we started at 3.0 milliliters, and we ended around, with our equivalence point, around 37.0 milliliters. And so you can use the data with the time-dependent or the volume-dependent measurements that we've just completed in the video, and you can use that to plot your pH versus volume curves to also get the first and second derivatives for your calculations. Thank you.